subjected to a UDL load of 10 kilonewton per meter for its entire span. The section of the beam is hollow rectangular with outer dimension and inner dimensions of 100 by 100 and 50 by 50 mm respectively, with the uniform thickness of 25 mm. So stop. Determine the maximum shear stress and sketch shear stress distribution diagram. Okay. So first of all, the beam it is given simply supported. This one beam it is given simply supported, and uniformly distributed load it is acted on that beam. Uniformly distributed load it is acted on that beam. So uniformly distributed load it is 10 kilonewton per meter. It is acted 10 kilonewton per meter. Okay. So loading it is 10 kilonewton per meter. 10 kilonewton per meter. And span it is given how much? 5 meter. Span it is given 5 meter. 5 meter. Okay. So reaction it will be, that is shear force it is equal to, I can say it will be shear force or reaction of this beam. It is WL by 2. Okay. So load it is W into L divided by 2. W into L divided by 2. W into L divided by 2. So W it is here 10 kilonewton per meter. Span it is 5 meter divided by 2. Divided by 2. Okay. So shear force it will be get 25 kilonewton. 25 kilonewton. Okay. So this one it is shear force. Okay. So I can write down S is equal to here 25 kilonewton. Okay. I will note down this value. S is equal to this 25 kilonewton. Okay. So next, calculate moment of inertia for this section, hollow rectangular section. Moment of inertia. Moment of inertia for hollow section, it will be Ixx is equal to 1 by 12, 1 by 12, 1 by 12, 1 by 12 in bracket B into capital D cube, B into capital BD cube minus small bd cube, minus small bd cube, means small inner width and depth, inner width and depth, inner width and depth, inner width and depth is equal to, put all this value here, is equal to 1 by 12, 1 by 12, 1 by 12, 1 by 12 in bracket, capital B it is 100 into capital D it is also 100, till it is square rectangular section, 100 into 100 minus inner dimension it is 50 into 50, 50 into 50 cube by 12, 50 cube by 12. Okay, it will get moment of inertia from this. Okay, you get moment of inertia from this. So Ixx is equal to, calculate this value, 1 by 12 into 100 cap 4 minus 50 cap 4 into 1 by 12. Okay. It will get 7.8125 into 10 raised to the power 6, 10 raised to the power 6 mm raised to 4, mm raised to 4. Okay, so this one it is moment of inertia. Okay. So note down this value, it is also 7. I is equal to 7.8125 into 10 raised to the power 6 mm raised to 4. Okay. So now calculate the shear stresses. Okay. Shear stress, we will calculate one by one. Shear stress. Okay. So this one it is neutral axis of this beam. So above the neutral axis. So this distance it is total overall depth it is 50, means that is 50 in above the neutral axis it is 50 and below the neutral axis is 50 because of symmetrical rectangular section. Okay, 50, 50. Okay, so now calculate shear stress at junction between 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 you can say this one it is between. Okay, so I will show which we will consider. So this one it is area we are considering. Okay, for that. Okay, shear stress at junction between this distance. Okay, between hatched portion and unhatched portion, means this distance. Okay, you can say, you can't say it will be hatched portion, so there will be proper word for that. Okay, okay. So shear stress between, so hatched portion, you can say it will be hatched portion and hatched portion and above neutral axis unhatched portion, above neutral axis unhatched portion. Okay, portion. Okay, so Q1 is equal to, by considering width by considering width considering width B is equal to 100 mm. B is equal to 100 mm. B is equal to 100 mm. Okay. Q1 is equal to SA y bar divided by IB. S into A into y bar divided by IB. Y bar divided by I into B. I into B. Okay. I into B. So shear force it is, they calculated is 25 kilonewton. Here area it will be, first area is equal to 100 into 25. 100 into 25. Okay. So which portion? So this depth. Okay. So this depth it is 25 mm. Okay. So this depth it is 25 mm. Okay. So this one it is 25 mm. 25 mm. Okay. So this depth it is 25 mm. Okay. So that's why area it is 100 into 25. 100 into 25. So it will be 2500 mm square. Okay. Then y bar is equal to so 25 minus 50. This distance will be first calculate. So this distance above the neutral axis up to here, 25 minus 50 will be, so this one it will be 25. Y bar is equal to now 25 plus 25 by 2. 25 by 2. Okay. So 25 plus 25 by 2. So this one it is 37.5. 37.5 mm. Okay. Put all this value here. So yes, it is 25 kilonewton. Convert it is in Newton. Area it is 2500. Then y bar it is 37.5. 37.5 divided by I into B. So I we are calculated it is 7.81 8125 into 10 raised to the power 3, sorry 6 into B it is 100 m, and it will get Q1 value from this relation. So 25 into 10 raised to the power 3 into 2500 into 37.5 divided by 7.8125 into 10 raised to the power 6 into 100. Q1 value it will get 3 ampere. 3 ampere. Okay. So now Q2, shear stress at junction same. Shear stress at junction between shear stress at junction between hatched portion and unhatched portion and unhatched portion by considering B is equal to here. So B is equal to 25 into 2. 25 into 2, that is 50 m. That is 50 m. Okay. So Q2 is equal to 3 into first width we have considered it is 100 divided by, now we are considering width it is 50 m. Okay. So removing the Q1 equation, we are removing 100 and we are putting there 50 m. Okay. So that is 6 ampere. 6 ampere. Okay. 6 ampere. Okay. So this one it is Q1 and Q2. Okay. One, I will note down Q1 value it is 3 ampere and Q2 value it is 6 ampere. Now calculate Q additional. Okay. We need to calculate Q additional. Q additional is equal to additional. That is means which portion here? Here. Q additional it is this hash portion. Okay. So this portion it is Q additional. Okay. So write down equation here. S into A into Y bar divided by I into B. Okay. Okay. So I into B. Okay. Okay. So here area it will be, so there are this width it is 25 and height it is also 25. So 2 into 25 into 25. 2 into 25 into 25. So total it will be get 2 into 25 into 25. It will be 1250 mm square. 1250 mm square. 1250 mm square. And Y bar it is 25 by 2. 25 by 2. So it will be 12.5 mm. 12.5 mm. Okay. Now put all this value here. Yes, it is 25 into 10 raised to the power 3 area it is 1250 into y bar it is 12.5 divided by I into moment of inertia it is 7.8125 into 10 raised to the power 6 into width. Here we are considering width, it is width we are considering here 25 mm. Okay, so this 25 width, that is total width, it will be get 50 mm. Okay, so 25 plus 25 50. Okay, total width it is 50. So width 25 plus 25, both sides it will be this 25 we are adding and this 25. So 25 into 10 raised to the power 3 into 1250 into 12.5 divided by 7.8125 into 10 raised to the power 6 into 50. Okay. So Q additional it will be get 1 MP. 1 MP. Okay. Just Q additional. Just I will once again I will do the calculation. 25 into 10 raised to the power 3 into 1250 into 12.5 divided by 7.8125 into 10 raised to the power 6 into 50. 1 MP. So it is 1 MP. Okay. So this one it is Q additional. So Q max is equal to Q max is equal to Q max is equal to Q2 plus Q additional. Q2 plus Q additional. So Q2 we are calculated 6 MPa. 6 plus 1. Q additional it is 1. So it will be 7 MPa. M. So Q max it is 7 MPa. So Q max it is 7 MPa. And Q additional we are calculated this one it is 1 MPa. Okay. So now draw the shear stress diagram. Okay. So this one it is Q max diagram. Okay. So we'll draw the shear stress diagram. First of all, draw the reference line for that. These are the reference line. Okay. So Q1 value it is 3 MPa. So for bottom and top it will be same because of symmetrical. Then Q2 value it is 6. Q2 value it is 6. Q2 value it is 6. And Q max it is 7 MPa. Q max is 7. So this distance it is Q max. So this one it is 7 MPa. Q max is equal to 7 MPa. 7 MPa. Okay. Then Q1 is equal to 3 MPa. Q2 is equal to 6 MPa. 6 M. Okay. And Q additional it will be this distance will be called Q additional. Okay. So this distance. So this distance we call it is Q additional. Okay. This distance we call it is Q additional. Q additional is equal to it will be 1 MPa. 1 MPa. 1 MPa. Okay. So this one it is stress diagram for the hollow rectangle section. Okay.